when I come up here, you see I've got normally open contact, normally closed contact, and then I've got assignment. What do these mean? Well, I'm going to pull these things down and put one here, and I'm going to drop an assignment on each one of these. Okay, so let's say I've got some input here. I'm going to call that input 1. And I'm going to use the same input here, so I also have an input 1. And then I'm going to have an output 1 here and an output 2 down here. Okay, so these two outputs, output 1 and output 2, they are never going to be energized at the same time. Why is that? Because input 1 can only ever be true or false at a particular time. So what these two normally open and normally closed contacts, that's great what they're called, but let me tell you what they really mean. You see here this input 1, this is going to represent a Boolean, okay? So that Boolean is going to be a digital signal. It's either true or false, open or closed, 1 or 0. It's only got two possible values. If that value is true, i.e. it equals 1, then this condition is going to be evaluated as true, and we're going to go ahead and energize output 1. This condition right here is only going to be true when its associated bit is false. Okay? So if this is false, then this is going to happen. But if input 1 is true, then this is going to happen. Okay? So what these two symbols here do, these normally open, normally closed contacts, those are going to work in direct opposition of one another. They're opposite functions. This is called examine if closed. This is called examine if opened. So if input 1 is closed, i.e. true, then go ahead and do what's to the right. If input 1 is open, meaning not true, then go ahead and do what's on the right. Okay, so coming in here and scrolling down, actually I'm going to add a couple of things. I want to talk to you about latches, and I want to talk to you about one-shots. So when we come up here, and we're just going to go ahead and get rid of this network 2 right now, because that doesn't have anything to do with what I'm about to talk about next. What network 1, what this rung does is when this evaluates true, this will be true as well. That's why it's called assignment, because it's assigning what's over here. If this all evaluates true, it's assigning true to this. If all this over here evaluates as false, it assigns false to this. That's why that's called assignment. But only while this is true will this be true. But what if we want something that once this becomes true, it sets this to true, and even if this becomes false, it leaves this as true? Well, we've got that. So I'm going to come over here and copy that, Control C, come down here and Control V to paste that in. And now I'm going to use this set output, which is not assignment. And I'll go ahead and call that output 2. See how this one's got that little S in the middle of the symbol, right? Now you know what this one does. Once this becomes true, it's going to make output 2 true. Then when this becomes false again, output 2 will still be true. It stays that way. And if input 1 becomes true again, output 2 is already true, so nothing really changes. So how do we unset output 2? Well, we can come down here and give ourselves another condition, and this time we'll make it a different input, input 2. And now we'll use reset output, and we will tie that to the same output 2. So now when input 2 becomes true, we reset or make it false output 2. If output 2 is already false when we evaluate input 2 and it's true, obviously nothing changes. We're making something that's already false false, which leaves it false. But here's the thing. Take a look at this. I'm controlling output 2, and I'm setting it and making it true in one place, and I'm resetting it or making it false in another place. I've got 2 different rungs in 2 different networks controlling that. I'm going to copy my input one more time and put that down here. And I've got a few different controls that I can use for this. I've got P, well, that's not it. Let's come down here. There we go. The ones I want to show you are, I've got P trig, I've got N trig, I've got R trig, and I've got F trig. Okay? Well, P and R are basically the same thing. P is positive, R is rising. And negative, N is negative, and F is falling. And those are basically kind of the same thing as well. Let me explain. We're going to go down here, and I'm going to create a couple of different little branches here. So let's just give ourselves something to work with. And actually, I'm just going to look at one set of these. So I'm going to put a positive P right here. Those are the ones I like, and then we're going to put an R right here. Okay, so you see that one actually requires its own data block. And then look over here. You see how we've got this, right here we've got a CLK and a Q. Okay, so this gives us something to evaluate, and it outputs something. This other one gives us these energize, which allows us to enable this block, and then we have this ENO, energized output, which basically tells us when it's been energized. Okay, that's a lot of extra bells and whistles that we really don't need. So I'm going to say if you want to experiment with R trig and F trig, be my guest. But really, all you need to know is the P trig. And the you can obviously use the N trig as well, which is just the opposite. So let's go ahead and get rid of this. I'm just going to delete that out of there. And I'm going to delete this R, this reset, because we're not going to be using that. Okay, so what happens here? When we've got this Q, when this thing gets energized, something over here is going to happen. And let's say we're going to be triggering something. Ah, there we go. So I'm just going to put a trigger, and this will be a Boolean here. So when input 2 happens, when it becomes true, as soon as it becomes true, this trigger is going to become true also, but for only one scan. And then after that, even if this input 2 remains true for the next 100,000 scans, trigger will not become true again. If we want trigger to become true again, we have to release input 2, and then when it becomes true again, then we'll fire the trigger one more time. For this P trig, you see right here it's looking for a Boolean, and that's to store the value of CLK from the previous scan in. That's what it compares against to know whether it's transitioned this scan or not. I want to give you a hint. You definitely want to use a global memory here. So I'll just put in, I'll call it ONS, define tag. If I use local temp memory, okay, basically this trigger is going to be true the whole time while input 2 is energized, because this memory is very volatile. It doesn't retain its value from scan to scan. Okay, So what can I do? I can use local static, or I can use global memory.